Hello, welcome back to Temp Talk. Today we're going to talk about process heating, specifically about electric process heating and what that means to you in your facility. Process heating is used in a lot of different applications for a lot of different things. Process heating could cook cookies, it could cook a large tank of tar, it could produce high precision temperatures in a gas line in a semiconductor facility. Here at Powerblanket, we're specialists in electric process heating. When we talk about the thermal loop, the heater is the part of the thermal loop that delivers the heat to the process. Where process heating is a term that refers to heating things in general for a process or a given output, electric process heating is specific to the use of electric heaters in the process of heating a product or a process. Electric heaters have a resistor inside of them that when voltage is applied, resistance is created. It's that resistance that creates the heat. And it's that heat that needs to be monitored by the temperature sensor and the input to the temperature controller, which controls the output to the relay and modulates the heater to keep your process at the correct temperature. There just aren't many industrial facilities that don't employ some form of electric process heaters. They can be used to heat lube oils. They can be used to heat gas streams. They can be used to keep tanks warm. There's just dozens of applications. A circulation heater, for example, can be used to heat a fuel gas stream going to a turbine. One of the most important things in a turbine is not have any water in the stream. When that gas travels through our circulation heater and goes to a fuel gas heater, it can knock out all of the water. They're actually called dew point heaters. Immersion heaters can be put into vessels that heat anhydrous or aqueous ammonia for NOx control systems. So the pollution control systems in any plant that emits nitrous oxide is actually being controlled by an electric heater that vaporizes ammonia in process. Immersion heaters are at the core of the offering of the typical electric process heater. Powerblanket's an expert in immersion heaters, and they really come in three main types. The first type is an over-the-side heater. The second type is a flanged immersion heater, and the third type is a screw plug heater. Over-the-side heaters literally hang over the side and can be immersed in a liquid like waters or plating materials, and they can keep that whole tank well warm. It's a very easy application to do and very easy to install. They typically can be very tall and very long because the depth of the tank can be longer, but the heat never starts till the very end of the heater. The most common configuration is actually an L-shaped. So the long side of the L typically isn't heated, but the L side is. And so really it just matters how you get down to the bottom of that tank. They sit on the bottom of the tank, they deliver heat into the process, and they're very, very reliable. Flanged immersion heaters are at the core of the offering of immersion heaters. They always use an ANSI flange, a flange that's sized by pressure and diameter. So common flanges can come in something about 3-inch in diameter to units I've seen way over 30 inches in diameter. They have bolts that connect them to a mating flange in some sort of a process. They could be in a vessel for a process heating application with a circulation heater. They could be bolted into a tank. They could be bolted into many applications where heat transfer has to occur in that process. Flanged immersion heaters are able to be Class 1 Div 1 and Class 1 Div 2 certified. They can also be rated for ASME design and pressure ratings. So they're an ASME rated product. So they can be installed into an ASME vessel. These heaters often deliver a great deal of heat in a short period of time. So one of the things that's most important on these heaters is the protection of the heater from runaway or overtemp protection. And they'll almost always build an overtemp thermocouple on the surface of the heater so that the end user knows that the heater itself doesn't overheat and run away. Pipe insert immersion heaters are another type of flanged immersion heater that have gained a great deal of popularity in about the last 10 years. It's really common for people to kill their steam coils and put a pipe insert immersion heater right over the top of their steam coils. Pipe insert immersion heaters work really well because they actually have a heated well in them. They take a flange, and where normal flanged immersion heaters have heating elements that are installed into the tank, when that normal flanged immersion heater is installed into a tank, you have to drain the entire tank to replace the heater. With a pipe insert immersion heater, they've actually welded a Schedule 40 pipe or multiple Schedule 40 pipes onto the face of an ANSI flange. Then that whole assembly gets installed inside the tank. What you have are heated wells with heaters on the inside of them. so that when maintenance needs to be done on the heater, you don't have to drain the tank and your process can keep running. You open up the terminal box and you pull the heaters out of the wells and then you place them with a brand new one. Pipe inserted immersion heaters can really add a lot of efficiency to your process. Electric heat is 100% efficient in delivering wattage into your process, and it works a lot better than steam coils. And actually, for a lot of tank heating applications, it works a lot better than a screw plug or a flanged immersion heater will. Screw plug heaters are kind of like the duct tape of the immersion heater application industry. They're used for a lot of different things. They can be screwed in by a connection that's called an NPT connection, National Pipe Thread. And so just like on piping that has threads, it is designed to thread only to a certain point, then you can no longer tighten it anymore. So it's got a nice seal to it, multiple threads. They can bear a lot of pressure, and the wattages you can get out of screw plug heaters is pretty impressive. So you can get from anywhere from a little bitty 500 watt unit like the ones in your water heater at home, all the way to one that's probably 40 feet long. The connection never gets bigger than 2.5 inch NPT, and that's what makes them so universal. A lot of tanks that are in operation that need a lot of extra heat, like in the oil field, for example, for day tanks, they have a lot of extra 2 inch and 2.5 inch connections at the bottom of the tank. So it's really easy to drain the tank and stick the heater in the application and twist them in. Screw plug heaters are very reliable, very rugged. They can be controlled with a local thermostat, and they perform very well in a lot of rugged applications. Immersion heaters are a very specific type of electric process heater. Most of the time, immersion heaters are put into a tank to keep a level of liquid at a certain temperature. Whether it's a flanged immersion heater, a pipe insert immersion heater, an over-the-side heater, or a screw plug heater, your tank heaters need to be keeping that tank at a certain temperature. The problem is sometimes the contents of that tank can't see temperatures that are of a certain rate. So you have to protect that product from the heater. In other words, if the heater runs away and gets to 800 degrees, it may catch something on fire. So what a lot of people do is take that over the side or screw plug or flanged immersion heater and they put a thermocouple or a thermostat on the sheath of the heater just for over temp protection. On the other side of things, from a control standpoint, usually you've got a very large mass of product in a tank, a lot of tar or liquids of some sort, biodiesel. And when you apply heat to that process, it just doesn't heat up very fast. It's dozens of hours for it to change temperature. So the type of control that's most commonly used when we talk about the thermal loop is just an on-off or a proportional controller. There's no need to be turning that heater off and on multiple times per second, keeping a very precise temperature. On-off and proportional controllers do a fantastic job of keeping the product at a stable temperature when the insulation system is working well. Another thing that's very important is where your sensor is placed. So in the thermal loop, the sensor plays a critical role in making sure that the sensor is measuring the temperature of your product where it needs to be measured. In a tank, it often occurs that a person puts a sensor way up at the top of the tank and the heater's way at the bottom of the tank. If the tank level goes down, then the sensor is actually sensing air temperature and not liquid temperature. Be sure that you put your level controller and your sensor at the level of the heater so that you're measuring the tank contents all the way down to where the heater is. Because once the tank level goes below the heater, your level control system should really shut your heater off. Circulation heaters are probably the most sophisticated type of electric process heater out there. They really are a heat exchanger. An electric heater is placed into a vessel or a chamber, and the elements hang out into the chamber. The vessel has an inlet and an outlet that are flanged connections normally to a process, and product flows through that heater out into a process. So heat is exchanged from the electric heater to the product flowing through it. Electric process heaters can come from a very small size that you could hold in your hand all the way to something bigger than a school bus. They can handle pressures from 1 psi or low psi all the way to 5,000 psi. Circulation heaters as a process heater are really pretty sophisticated, like I mentioned before. They take a high level of control. When product is flowing through our heater, it's usually going to some critical process that has to receive its product at a very precise temperature. So the control system on a circulation heater really needs to modulate that heater at a high rate and make corrections if the flow varies a little bit or if the temperature needs to change at the process. Typically, circulation heaters, in terms of the thermal loop, need a very precise controller. They would require a PID controller for a temperature controller. They would require an SCR to fire the voltage to the heater, and they would require a sensor placed right at the outlet of the heater to make sure that product was leaving the circulation heater at the correct temperature. These heaters have to make corrections in multiple times per second. They have to react quickly to process conditions, and they have to deliver performance time and again to your process. When you give us a call, our team is ready to discuss any application that you might have. Some of the most common things that you might need to know is, how big is the thing that you're heating? Is it a tank? Is it a reservoir? Is it a pipe? What are you trying to heat? The next thing is, how fast do you want to heat it up? Do you want to do it in a couple of hours? Do you want to do it in 5 minutes? Another thing that's really important to know is the voltage. Do you have 120 volt single phase, or do you have 480 volt three phase? Having that power available is really important, and your facility has to be able to accommodate this heater once it's installed. Another thing is, tell us a little bit about your application and what you're trying to accomplish. When you're designing a process heater, we need to know the process ranges. What pressures are there? What temperatures need to be gotten to? What are the bad temperatures and what are the good temperatures? Overall, what can you tell us about your process so we can know for sure that we designed the right heater for the right application? Electric process heaters are mechanical in nature. They do run on electricity, but for the most part, they bear pressure and they go to high and low temperatures. So there's a lot of things that can go wrong with them. How do you tell if your heater needs to be replaced? A couple of things that are really obvious is, number one, if the performance reduces when power is applied, you know that you've lost heating elements or the ability to create heat, or maybe you've lost some heating elements. Heating elements, like any mechanical device, lose about 5% of their performance every 5 years. Sometimes when other things come into play, they'll go faster or slower. I've seen electric heaters in process for over 30 years, but I've seen some that have gone out in 1 year. Electric process heaters can get attacked by corrosives because the heating element itself is the hottest portion of the process. The hottest portion is always the part that gets attacked first. So corrosion is a big issue with electric heaters, and you can't always see corrosion in electric process heaters. It occurs inside of the process. So a great preventative maintenance program over time, where you pull that heater out of process and actually take a look at it, is going to help you understand if you've lost elements or if you're having any corrosion issues. In 25 years, I've seen a lot of funny things. Electric heaters don't like water. And one example is, I had a customer who had a lot of very large 365 kilowatt circulation heaters vertically installed. So the terminal box was on top. Well, while these units were being stored in the yard, they left them in the open air and the terminal boxes were taken off. And they filled with water as rainstorms came through the winter. When springtime came and they decided to install these in the process, they rolled the terminal box over and bolted them shut. So when commissioning time came, they didn't work. Inside of a heating element is a product called magnesium oxide. It doesn't like water. And with about 6 inches of water sitting on top of those elements, it just absorbed all of them in there. So then when they went to turn the heaters on, they didn't work because they were all shorted out. Electric process heaters are installed in your process, so it's really important that they run really well over a long period of time. And just like with your own car, you got to have a good preventative maintenance program for your heaters. A good preventative maintenance program would include several things. First of all, it would include that you check that each circuit in your electric heater is pulling the proper amperage from when it was built brand new. Again, a 100 kilowatt electric circulation heater, for example, should pull a grand total on 480 volts three phase of about 120 amps. If you ask for full power and you only see 80 amps, you know you've lost some heating elements, so you need to go check them. Electric heating elements also have resistance to ground. That is, that there's a resistor suspended in the middle of a heating element. When that resistor actually touches the inside of the heating element, it'll short out. There's a way you can check to see if your heating element has potential to ground. It's called a megger. Meg-ohm resistance check is taking a meter that can go from about 1,000 to 5,000 volts DC. You apply it to the heating elements and you crank it up and you can see if you've got resistance to ground. In other words, megging your heating elements is probably one of the best ways to really check your heater to make sure that it's not going to short out on you. Corrosion is another thing that occurs in electric process heaters. Because you're heating chemicals or there's product around that can corrode the heating elements, it's really important to pull that heater out. Realize that the electric heating element is the hottest part of the process. So the hottest part always gets attacked first. What you want to look for is stitching or some sort of a corrosion or a white corrosion or a thinning of the element. That can cause a short to ground on the electric heaters also. So be careful to look for signs of corrosion on your electric heating elements inside of your process. That means you have to pull the heater out of the process. So part of your preventive maintenance program should include that you pull the heater out of the process and get a good physical look at it. Electric process heaters come in a variety of sizes and shapes. They're in your facilities, and your preventive maintenance programs will sometimes require you to evaluate or replace your electric heaters. Powerblanket offers the complete thermal solution from the temperature controller to the relay to the heater itself and the temperature sensor. When you're looking for a solution to replace the heater or for a new application, give us a call. Powerblanket offers complete thermal solutions, and when it comes to process heating, Powerblanket has you covered.